For the following data, determine the missing frequency y if the arithmetic mean is 6.2. To solve this, we have x column, f column. We write down the value 2468 and 2y69. And now we are dealing with arithmetic mean. And since we are dealing with arithmetic mean, we need to compute the xf column. And xf is computed this way: 2 2s are 4, 4 into y is 4y, 6 into 6 is 36, 8 9s are 72. So now the xf is given by, so now xf is given by this total, basically the total. This is how we calculate mean: 112 plus 4y. You can see we add all the numbers and we keep this 4y separate. Similarly, the sum of n, basically this is the procedure that we follow to find mean, and this is 17 by 1. Now arithmetic mean x bar is nothing but sum of xf upon sum of f. Sum of xf is 112 plus 4y. Sum of a is nothing but 17 plus y. And x bar is nothing but 6.2. So therefore 6.2 into 17 plus y is equal to 112 plus 4y. 6.7 into 17. Now this is actually entering inside and it distributes to both. 6.2 into 17 plus 6.2 into y, and this is 112 plus 4y. Now 6.2 into 17 using calculator is 105.4 plus 6.2y is equal to 112 plus 4y. So we now have 6.2y minus 4y is equal to 112 minus 105.4. So we have 2.2y, which is equal to 6.6, and therefore y is 6.6 upon 2.2, which is 3. This solves the problem. We now move to the next problem, in which the annual profit earned by 100 companies during the financial year 2000-2001 are given. Draw the OJEFs using less than and more than method, and hence find median. To solve this, we need to draw a less than type OJEF and a more than type OJEF, and we shall draw this on the same graph, and using the graph itself we will find out the median. So our goal is to first draw a less than type OJEF and a more than type OJEF on the same graph, and using it we shall find out a median. So now to draw the less than type OJEF, we need cumulative frequencies of less than type. These are calculated as follows. There is an X column which we create, and there is a CF column that will create. Now in the X column we insert all the values: 0, 30, 0, 30, 60. Basically we insert all these values which are there, not as class interval, but basically the numerical values: 120, 150. Now CF we first create of less than type. So the first value will be 20. We take the first value always as 0. Then we do 0 plus 20, which is 20, 50, 75. Basically we add these numbers: 20 plus 30, 50 plus 25, 75 plus 20 will be 95, and 95 plus 5 will be 100. This creates CF. Now this CF will be used to draw less than type OJEF. At the same time, we shall create a CF of more than type, and this shall be used to draw the more than type OJEF. So for that we start with the first entry is definitely the total which is 100, and we now keep on subtracting. So first we do 100 minus the first entry which is 20, we get 80. 80 minus 30 we get 50. 50 minus 25 we get 25. 25 minus 20 we get 5. 5 minus 5 we get 0. Now on a same graph we have to draw the less than OJEF and a more than OJEF. And to draw this, we plot the x values. Now if you observe, all the x values are at a gap of 30 from 0 to 90. Therefore, we plot it as follows. 0 is here, 30 is here, 60, 90, 120, 150. The y values are at a gap of, we can take the values, gap of 10 values, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are the x values. These are the CF values. Now, if you look at the x values, now we are plotting a less than type ogive, so we shall only look at these two columns. So when x is 0, the CF is 0, so this is done. When x is 30, CF is 20. For 60, it is 50. For 90, it is 75. For 120, it is 95. And this is 100. So when we draw this, we shall get something like this. This is called less than ogive. Now on the same graph, we have to draw more than type ogive, in which we shall do the calculation in which we shall plot the first and the third column. So for 0 it is 100, so that means we are there. For 30 it is 80. For 60 it is 50. For 90 it is 25. 120 it is 5. And 150 it is 0. So when we plot this, we get the graph as follows. Now this is your more than ogive. Now we are also told to find the median. Now the median is basically the point where both these curves intersect. You can observe the value 60, both these values intersects. So that means from the intersection point, you have to drop down a line and see it coincides to which point on the x-axis. So to find median, at the point of intersection of both these curves, drop down a line and see where it intersects with the x-axis. This is called median, and therefore the median is nothing but 60. This solves the problem. So we have to draw less than type, we have to calculate cumulative frequencies of less than type, cumulative frequencies more than type, draw the ogive of less than type, more than type, and therefore find the median. Now we solve the next problem. The average salary of 100 male workers in our company is 40,000, and the average salary of 110 female workers is 42,000. Determine the average salary of 210 workers taken in the all take in the company together. Fine. So we have those two groups. Basically, one is the male, the other one is the female. Now, male, the number of males, which we shall call it N1, is nothing but 100, because there are 100 males. Number of females, we shall call it N2, and these are 110. The average salary is 40,000, we shall call it X1 bar. Basically, this is the mean of group 1. Average is nothing but mean, so it is mean of group 1. Similarly, the average salary of 110 female workers is X2 bar is 42,000. Now we have to find the average salary of 210 workers. So to combine this thing, we have a formula. The formula is nothing but X bar is equal to N1 X1 bar plus N2 X2 bar upon N1 plus N2. So we use N1 as 100, X1 bar is 40,000 plus N2 is 110 into 42,000 upon N1 plus N2 is 100 plus 110. Calculations will tell us that this is nothing but two more zeros will add. This will be 462 4 zeros upon 210 and divide by and doing the further calculation, we get the answer as 41047.61. This solves the problem. We move to the next one. So basically in this problem, we have to identify the two groups, find the number of individual in each group and find the average of each group. And to find the combined average, we have to use this formula, which is stated here. Okay. We now move to solve the following problem. Runs scored by batsmen in 5 games in a tournament are given below. Using appropriate measure of dispersion, determine which batsman is more consistent in the tournament. So the solution is simple. We basically will find out the standard deviation of batsman A and standard deviation of batsman B. Whichever batsman has more standard deviation will be less consistent. So more SD implies less consistent. So therefore, but we are told to select a batsman who is more consistent. That means the SD has to be less. We have to select a batsman which has got less SD. So our goal is to now find SD. Now we are given X values. So we insert the X values. And when only X values are given, the standard deviation is calculated by root of summation of X square upon N minus X bar square. So basically we now write down all these things, whatever all the entries are there for X. We do it as 12, 50, 53, 40, 32. Now we create your X square column. To create your X square column, use 12 square, which is 144. Basically, we find out the squares of the entries. 50 square is nothing but 2500. 53 square will be 2809. 40 square is 1600. 32 square is 1024. Therefore, we get the sum of entries in X square column. Now, basically, we need to know the sum of entries in the X square column. Now, so therefore, we find out first sum of X. Sum of X will be the entries in the X column. Now, basically, this sum is nothing but 12 plus 50 plus 53 plus 40 plus 32. This sum comes to 187. Now we have to also find sum of X square. Sum of X square is nothing but 144 plus 2500 plus 2809 plus 1600 plus 1024. This sum is 8097. Now if you also we need to find X bar here. So X bar is nothing but sum of X upon N. So this is actually 187. N is 5 entries. So therefore 187 divided by 5 will be 37.4. Now we shall insert everything in this formula and obtain the answer. So SD, which is nothing but summation of X square upon N minus X bar square. So the numerator summation of X square is nothing but 8077. We had found N as earlier 5 and this one was obtained as 37.4. Now basically we did not touch the root sign. We'll first find what is 8077 divided by 5. The answer is 1619.4, and then we do 37.4 square, which is 1398.76. Cancelling in the roots and we get the answer as root of, when we cancel it off, the answer that is obtained is 1615.4 minus 1398.76. This answer is 216.64, and under root we get the answer as 14.6. 7.1. So this is the standard deviation for batsman A. Similarly, we have to calculate standard deviation for batsman B. Same procedure has to be done for batsman B also. And the one having less standard deviation will be preferred. We move to the next question. A frequency distribution gives the following coefficient of variation. Coefficient of variation is COV is nothing but 5. Standard deviation is sigma, which is 2. Carl Pearson's coefficient of skewness is 0.5. We use the formula for COV. COV is SD upon mean into 100. Now, COV is 5, SD is 2. We have to find mean. So we can get mean from this. You can get 5 mean is equal to 200, and therefore you get mean is equal to 200 upon 5, which is 40. Now, this gives us mean. Now, so we have found out the mean. Now our job is to find mode. So for this, we use the other information that is given to us, the information regarding SK that is given to us. So we use this SK information to find the other option. Now SK has two formulas, mean minus mode upon SD, or 3 times mean minus median upon SD. But since we are finding mode, we will use SK to be mean minus mode upon SD. Now SK's value is 0.5, mean we found as 40, mode is something we should find, SD is something that is 2. So therefore we get 0.5 into 2 is equal to 40 minus mode. So 1 is equal to 40 minus mode. So therefore we get 1 plus mode is equal to 40. Therefore we get mode is equal to 40 minus 1, which is 39. This solves the problem. We move further. So basically in this problem, we have used the information, whatever is available. We have used the information about COV, we have used the formula for Carl Pearson, and we got what is mean and mode. So basic idea is we should work with whatever is available, whatever formulas are available, and try to approach the answer. Now we move to the next one. A worker earned 25,000 in 2000. The cost of living index goes up from 110 to 170. How much income should the worker earn in 2015 so that he could afford the same standard of living in 2015 as in 2000? So there are 2 years. One is 2000, the other year is 2015. In 2000, he earned on his earnings were 25,000. Basically, this is also called his income. Now, the cost of living was 110. In 2015, we don't know what is his income. Basically, the idea is how much income the worker should earn. So this is something which we should find. And the cost of living index number is given as 170 for this. Now, in the first part, we calculate the real income. Real income has a formula. Formula is income upon cost of living index number multiplied by 100. So income is nothing but 25,000. Living index number is 110 upon 100. This real income will be, we shall find out this real income. $22,727. This answer comes down to 22,727.27. Now it is clearly mentioned over here, he could afford the same standard of living. That means the real income in 2000 should match with the real income in 2015. So now we use this fact to solve the further problem. We use the fact that real income, now this we are doing for 2015, will be income in 2015 upon cost of living index number multiplied by 100. Now real income, because its standard of living is same, the real income will be the same. That means it will be 22,227.27. The income we don't know is something which we should find. If you observe, income is something we have to find. The cost of living index number is nothing but 170 into 100. We do the calculation, 22,727.27 into 170 will be income into 100. So this answer 38,636.36 income upon, now we divide it by 100 to get the answer is 38,636.36. This is the answer. Now we move to the following problem. Given below are the data for the average workers of factory workers in Goa during the period 2000 to 2005. Calculate the real income of the worker. What is the real gain, if any, to the worker over the period? Now, so what we need to basically do is we should calculate the real income for all the years. That means now given below the data of average wages of a factory workers in Goa during period. Calculate the real income for the worker. So basically we have to calculate real income for 2000, real income for 2001, real income for 2002, real income for 2003, 2004, 2005. Now real income, I said, is nothing but income upon index number, or whatever is the index number available, into 100. So we are doing it now for 2000. So you'll realize that when you insert the income upon index number into 100, you will get 20,000. Now similarly, you have to calculate real income for 2001. In 2001, real income is nothing but the income upon price index number into 100. And this is nothing but 18333.33. Similarly, so if you observe, we are asked what is the real gain, if any, to the worker over this period. So if you observe, the real income in 2000 was 20,000. Now in 2001 it is 18,333.33. So there is no gain. The real income has fallen. Similar calculations have to be done for real income for 2002, in which we take the income as 23,500. The index number is nothing but 121. So 23,500 divided by 121 will fetch us 190 into 100, of course, 19,004 to 1.48. So now if you clearly observe that the real income now has increased from 18,333, it went to 19,421. So you can say that gain was 19,421.48 minus 18,333. The subtract, basically you have to subtract 18,333.33, and this will give us the answer is 18131 So you'll get the gain as 19,421 minus 18,333 1088.15. This was the gain. Similarly, a similar calculations have to be done for 2004, 2000. This was for 2002. We have to do 2003, 2004, 2005, and whichever year shows a increase, we have to show what by what it has increased. So for example, if I want to do 2003, it is 24,000 upon 129. So to do this, I use the following. So basically in this problem, we have to find the real income for all these mentioned years, which is income upon index number. And then if there is a gain, we have to show by what it has gained. This solves the